Hi there, this is Mr. Alexander, and today I'm here to talk to you about solving systems of equations with 3 variables and 3 equations using Gaussian elimination. Now remember that a system of equations is simply a series of, in this case, these are 3 lines, and we're simply trying to figure out where these lines intersect. And that's going to be an x, y, z coordinate. So these 3 lines, they intersect somewhere in 3-dimensional space, and we can figure out algebraically exactly where that happens. So I'm going to do a bunch of work here in Gaussian elimination, and what I'm going to find at the end is the point where these things cross. That'll be the end. Now to do this, I'm going to use these little set of instructions here that were given to you in class. We're going to be neat and systematic. We're not going to skip steps. And we're going to follow these outlines right here. So we're going to start at step number 1, where it says pick 2 equations and eliminate the x term. Well, let's look at these 3 equations real quick. I've got 3x plus y minus 2z equals 2. I'm going to call that equation 1. I've got x minus 2y plus z equals 3. I'm going to call that equation 2. And then I've got 2x minus y minus 3z equals 3. I'm going to call that equation 3. So I'm supposed to pick 2 equations and eliminate the x term. All right. Well, I'm going to go ahead and pick equation 1. And if I'm going to eliminate the x term, that means I'm going to have to add something. But the x term is going to have to be negative, and it's probably going to need to be a negative 3 to eliminate when I add them. So I need to multiply equation 2 by a factor of negative 3 so that those x terms will cancel out. Here's what I'm talking about. So I'm just going to copy down equation 1, which is 3x plus y minus 2z equals 2. And I'm going to copy down equation 2, except I'm going to multiply all 4 terms here by negative 3. So that's going to make it negative 3x. Negative 3 times negative 2 is positive 6y. Negative 3 times z is negative 3z. And then negative 3 times 3 is negative 9. Now I simply need to add these 2 equations together. So 3x minus 3x, that's 0. That's what I was trying to do. I was trying to eliminate the x term. Y plus 6y is 7y. Negative 2z plus negative 3z is negative 5z. And then 2 plus negative 9 is negative 7. Right here, I'm going to call this equation number 4. And that's step 1. We've picked 2 equations and we've eliminated the x term. Let's look at this list again. Step 2, pick 2 different equations and eliminate the x term. All right, so I picked 1 and 2, so now I got to pick 2 different ones. So I'm going to have to use 3. I know that. Let's use 3. So equation number 3, I guess I'll do it right here. Equation 3. And we'll add, let's see, this time I'm going to multiply equation 2 by negative 2 instead of negative 3. Negative 2 times equation 2 so that I can cancel out those x terms. All right, so let's copy down equation number 3, which is 2x minus y minus 3z equals 3. And let's copy down equation 2, except I'm going to multiply negative 2 throughout to make that negative 2x plus 4y minus 2z equals negative 6. I'm going to add those 2 equations together. And when I do that, the x's are eliminated. Negative y plus 4y is 3y. Negative 3z plus negative 2z is negative 5z. And then 3 plus negative 6 is negative 3. This is equation number 5. And we're done with step 2. All right, let's look at my list now. Step 3 says use the equations from 1 and 2 and eliminate the y term. Okay, eliminate the y term. So I'm looking at this thing. I need to use equation 4 and equation 5. I need to add them in such a way that these y terms are eliminated. Now the easiest way to do this every time is look at equation 5. The number in front there is a 3. So I'm going to multiply everything in equation 4 by 3. Now look at equation 4. What's the number in front of the y there? It's a 7. Let's go ahead and multiply everything in equation 5 by a 7. So I just took the other value in front of the y and I multiplied the equation by it. And let's see what happens when we do that. So 3 times equation 4 would be 3 times 7 is 21y. 3 times negative 5z is negative 15z. And then 3 times negative 7 is negative 21. 7 times equation 5 is 21. Oops. See, I already screwed up because this one of them needs to be positive, one of them needs to be negative. So I'm going to go ahead and multiply everything by negative 7 to make this a negative 21y, so that the y terms will be eliminated. Negative 7 times negative 5 is positive 35z. And then negative 7 times negative 7 times negative 3 is positive 21. All right, so I need to go ahead and add these things together. The y's are going to be eliminated. Negative 15 plus 35 is 20z. And the negative 21 plus 21 is 0. This is equation number 6. And we're done with step 3. So, let's go back to our list. Step 4, use one original equation, one equation from steps 1 or 2, and the equation found in step number 3 to write your Gaussian system. Alright, so we need to make a choice between equation 1, 2, or 3, and here's how you make that choice. You say, which one of those looks the easiest? I'm thinking it's equation 2. I'm going to write it right here. The equation 2, it's going to be x minus 2y plus z equals 3. And then we need to choose between 4 and 5. Which one of those looks prettier? I'm kind of thinking it's equation number 5. So I'm going to bring equation 5 over here. 3y minus 5z equals negative 3. And then you need to use equation 6 every single time, which in this case is just 20z equals 0. See this nice triangular shape here? This nice triangular shape, this is what makes it a Gaussian system. So the bottom always has one variable, the second one has 2 variables, and the top has 3 variables. That's what defines this to be a Gaussian system. So we've done step 4, and the last step is solve with substitution. And what that means is start from the bottom and work your way up. So let's start with equation number 6. We've got 20z equals 0. Solve it for z. Divide by 20 on both sides. Z equals 0. All right, so we've got z. Now we're working from the bottom up. So 6 to 5. I'm going to copy down equation number 5. 3y minus 5z, but now I know that z equals 0, so I'm just going to plug a 0 in there, equals negative 3. Well, that's 3y minus 5 times 0 is just 0. 3y equals negative 3. Divide both sides by 3, and you got y equals negative 1. All right, working from the bottom to the top, so now we're going to be at equation 2. And equation 2 is x minus 2y, but we know y is negative 1, plus z, which we know is 0, equals 3. So x minus 2 times negative 1 is positive 2, plus 0 is still positive 2, equals 3. Subtract 2 from both sides to get x equals 1. And you might think that we are done. But we're not, because I told you just about 9 minutes ago that we would do all this work to get a coordinate point. So you are not done until you tell me at the bottom here an x, y, z coordinate in that order, x, y, z. We found x to be 1, we found y to be negative 1, and z to be 0. This is the answer. This is why we use Gaussian elimination, to find that point where all of these lines intersect. And that's it. That's Gaussian elimination. Thank you for watching. Hope it was useful, and we'll see you in class.